This is section 4.4, and we're going to talk about real zeros of polynomials. And remember that a zero is an x-intercept. It's a solution. Another word for it is the zero. And the factor theorem we learned last section says a polynomial f of x has a factor x minus k if and only if f of k is 0. We talked about that. If the remainder is 0, then that means the thing went in without anything left over. So let's look at this picture. Here is a polynomial. It happens to be a quadratic. Here's your x-intercepts at -1 and 3. So those are the zeros, the solutions. The factors are when you put it in x minus whatever those numbers are. So this would be x minus a -1, which would be x plus 1. This would be x minus 3. So the zeros or the solutions are these. The factors of the thing are x plus 1 and x minus 3. If you did f of -1 and you did f of 3, you would get 0. So that proves that. Over here, you've got one intercept, and that real zero is k. So we don't have any numbers. We don't have any function. We just know y is f of x. So x minus k is a factor because k was the x-intercept here. So that's kind of just conceptually what we're talking about. Now, let's look here. On this function, it hits at -2. And remember, we said that meant -2 was a repeated root. So that's x plus 2 squared. That exponent says there's 2 of those. So that's a multiplicity of 2. Multiplicity. Now, on this one, these two x-intercepts, we got -1 and we've got 2. X plus 1 is a factor, and it says that's cubed. So there is a multiplicity of 3. And x minus 2, which doesn't have an exponent here, that's understood to be 1, so its multiplicity is 1. We will be asked about multiplicity in this section. Complete factored form if zeros are C1, C2, and C3. Well, it's just x minus those zeros. So x minus C1, x minus C2, x minus C3. No commas. These are factors. They're multiplied together. Write the complete factored form if given that the leading coefficient is 13 and the zeros are -1 and 2. So the factors, we do x minus this, so that's x plus 1, and x minus that, and 13 goes in front because that is the leading coefficient. All right. The 0, -3 has odd multiplicity of 3. This one has an even multiplicity of 2. And so that's the picture. This one's going through. This one's just touching. This 0 at -5 has an odd multiplicity of 1. This one has an odd multiplicity of 3, which you can't really see, but it's going and crossing, but there's more than one there. So it just says at a 0 of even multiplicity, the graph does not cross the x-axis, like here. At a 0 of odd multiplicity, the graph does cross the x-axis. The higher the multiplicity, the more the graph levels off near the 0. So let's go look at the problems and see how we're going to address that. All right, number 1 says use the graph and the factor theorem to list the factors. Well, first we needed to figure out what the zeros are. And you look at the graph and you come up with -5, -3, 3, and 5. So you simply put them in the x minus the number form. So this is x plus 5, x plus 3, x minus 3, x minus 5. And it says to list them separately, so they're not putting it as an f of x equals. They're saying what are the factors. So commas do go between these. Now, this one says write the complete factored form. We're not listing the factors. So we have zeros of 5 over 2 and 6. And we have a leading coefficient of 2 here. So 2 goes on the outside, and then we've got x minus 5 halves, parentheses x minus 6. Okay. Number 3, the zeros are -1, 4, and 3. So it's x plus 1, x minus 4, x minus 3. Type it in factored form. Use this graph to answer the following. So we need to know the leading coefficient. Well, we've got that here. So that's -3. The zeros are -4, 0, and 4. Write those with commas between. Now factor that, and we don't need to put x minus 0. That just doesn't have to be there. We should put it like this. Now that x should be there because the -3x will give us if we set that equal to 0, that would give us x equals 0. This will give us the x is -4. This will give us the x is 4. So leading coefficient -3. Here's your zeros. Here's how you write the factored form. Number 5. Find your zeros by the map. So we got -4, 4, and 7. Put those in the factored form, x plus 4, x minus 4, x minus 7. We want the complete factored form of this. Now we don't have a lot. We need to, this is a cubic. And so if we do f of x equals, we don't know about this a, but we know we've got x plus 3, x minus 2, and x minus 3. That's using those zeros there. So we need to know the y-intercept. And the y-intercept is right here. You know, they're going by 4 units. That looks like 0, 9. That it's probably going to be clearer on your computer. So y is your f of x. So 9 equals a times these factors. And when y is 9, x is 0. So put 0 for x there, there, and there. So now we have a times 3 times -2 times -3. And that becomes 9 is equal to 18a. Divide the 18 on the other side, and you get 1/2 equals a. So your final answer would be the 1/2 times those. And so that would be what's going to go in your box up top. All right. Number 7, use a graphing utility to graph the function and choose the correct graph. And it says the viewing rectangle is -8, 8, 1. Now, when they're saying that, remember that that's saying that this is your x min, comma, x max with a scale, this is your scale, of 1. And then over here for your y, it's your y min, y max. Oops, that didn't need to be there. Okay. And then your scale is 8. I just keep writing the things wrong. Y max is 72. And then that's your scale on this one. Okay. So when you're doing your window, when you go into y1, put this in your equation and change your window to match these so that you get the right graph here. When you do that, you should see version D. Write the complete factored form. How do we do that? What will we do? Let's go look at the calculator for this one. Okay, I have put this one in the calculator, and I put that in y1. I have 0 in y2. And then the window, I'll show you the window. I put in what that said, the negative 8, 8, scale of 1, negative 72, 72, and a scale of 8. And then when we hit graph, we do get D that looks like that. And write the complete factored form. Well, we need these. Now, we could probably see this is negative 2, 0, and 3. But if you didn't, remember that you'll just do second calc 5 for intersect and enter. You'll get 1, and then you'll do the others. So that should be pretty clear. And then the one that's at x equals 0 is the one that gets with the negative 4 at the front. So that'll be negative 4x, and then you'll have x plus 2 and x minus 3, because we had a negative 2 and a positive 3 up here. We had a negative 2, so that'll be the x plus 2. We had a positive 3, that'll be the x minus 3. So that's how we'll do that. Number 8, factor p of x into linear factors given that k is a 0 of p. So your k is negative 5. Now we don't have to change the sign on that because that's not in a x minus 4 or x plus 2 form. They're saying your k value is this. So that goes in your backwards L. Then we have 1, 8, 11, negative 20. And we do our synthetic division, we get 1, 3, negative 4. So this becomes x squared plus 3x minus 4. We'll factor that into x plus 4 and x minus 1. So you're just putting the 1 where the minus is, the 4 where the plus is. Number 9. Number 10, write the polynomial in completely factored form with leading coefficient 1 that satisfies these conditions. The zeros are negative 3 with a multiplicity of 2 and 5 with a multiplicity of 1. So that means x plus 3 squared. That multiplicity 2 gives you an exponent of 2. And the x minus 5 has a multiplicity of 1. So there's where we wrote that. And then you can put that in the calculator, and here's the window that you could use to try and match. So x min, x max, y min, y max, x scale 1, y scale 25, just like we did in the last one. You'll pick this, and this is what you're putting in y1. And it should look like this. 11, complete the following. So you've got x plus 2 squared. Find the x and y intercepts, determine the multiplicity, sketch a graph. So the x-intercepts are negative 2, 0, and that's multiplicity of 3. So that's it. There's 3 times that hits, okay? The y-intercept, how do we figure that out? The y-intercept occurs when x is 0. So y equals x plus 2 cubed. Put 0 there, and that's 2 cubed, which will be 8. So y equals 8. So you have 0, 8 for the y-intercept. The multiplicity of the 0 is 3. Use the graphing tool to graph the function on the computer. So I've pulled up this graph question, the part of the graph where it says to do it on the computer. And we know that this is a cubic function. So to start it, you would choose the cubic tool here. And it says, click on the, when you get a message, when you do that, it'll say click on the first point. So you know you've got 2 points to plot, negative 2, 0, 0, 8. And then it's going to ask you to plot 2 other points. So before you start trying to do that, you want to choose 2 other points. You could choose something for x and plug it in and get a y. So you actually have to have 4 points. 2 you've already got here, and you'll choose 2 more and then plot those 2, and you should get the correct graph like that. So that should help you with number 11. Number 12, let's look at number 12. Same idea. we've got x times x plus 1 squared times x minus 1. So our factors, the x gives you 0, 0. The 1 gives you negative 1, 0. And then the minus 1 gives you 1, 0. So those are the x-intercepts. And we would need a comma between them. I'll put that in. So those, be sure that you have the commas between them. The y-intercept, when we did that, I did that here. When x is 0, you've got 0 multiplied by all of these, and so it doesn't matter what these numbers are. Your answer is going to be 0. So the y-intercept is 0, 0. The multiplicity of the smallest 0 up here, the smallest 0 is negative 1. And so its multiplicity is 2. The middle one is 1, and the largest is 1. And then you can put this into your calculator, use the window that's given, and you should get your graph. Number 13, we are not doing this with graphing. We're solving this symbolically or by our algebra is what we're doing. So 3x cubed minus 27x equals 0. Factor that. Pull out 3x. You're left with x squared minus 9 equals 0. So this becomes one factor and gives you x is 0. This factors to x minus 3 and x plus 3, which gives you a positive 3 and a negative 3. So your three solutions are right there. For number 14, x cubed plus 1 equals 0. Subtract the 1 to the other side, and you've got x cubed equals negative 1. Well, negative 1 is the cube root of this, so the solution is negative 1. So we did some graphing, we did some factoring, and looking at putting into factors. And so that is 4.4, and that should get you done on that.